Hi everybody. In this video I'm going to show you how to work with satellite imagery in ArcMap, and before we get to working with things in ArcMap, I just wanted to really quickly remind you what satellites record and how they record it, because that's going to bear on how we work with it in ArcMap. So what you're looking at here is a slide showing two of the more recent LANDSAT satellite sensors, LANDSAT 7, which had the Enhanced Thematic Mapper, or ETM, and LANDSAT 8, which had the Operational Land Imager, or OLI. And these sensors are very sensitive. You can think of them as cameras that pick up certain wavelengths of electromagnetic radiation or light. And so this chart down here at the bottom is showing you two things. Number one, it's showing you in gray the percentage of light of different wavelengths, wavelength on the x-axis, that is able to go through the atmosphere. And so we're dealing with a satellite that is orbiting the Earth, and what it is able to see is of the surface is dependent on which wavelengths are able to actually penetrate through the atmosphere. And you can see here from this gray that some wavelengths of light are able to penetrate and go through the atmosphere quite well, whereas others do not. And effectively, for this wavelength of light, what this means is that the atmosphere is opaque to that wavelength of light, whereas it's transparent to some of these other ones that are shown in gray. Okay, so if we're orbiting a sensor around the Earth, we want to tune that sensor to pick up the wavelengths of light that are able to go through the atmosphere, because we're trying to image the Earth's surface. And so what these numbers here are showing are the numbered channels or bands that the sensor picks up, and the wavelengths of light that each of those bands corresponds to. So this on the top here is for Landsat 8, down here is for Landsat 7, and there are a number of other Landsat sensors that go back to the 1970s that have been imaging the surface of the Earth for quite some time. Visible light is down here in the short wavelength part of the spectrum, and so you'll see here that in Landsat 8, bands 4, 3, and 2 pick up what we register with our eyes as visible light, whereas in Landsat 7 imagery, bands 1, 2, and 3 are picking up that visible light. And those bands correspond to what we perceive as red and green and blue. But we also have all of these other bands out here, and all of these other bands are in the infrared portion of the spectrum, and these are basically picking up infrared light that things on the surface of the Earth emit. In infrared, we basically know of as heat for the most part. Okay, so that's a real brief introduction to Landsat imagery. And what we're going to do now is we're going to switch to ArcMap, and I am going to show you how to work with some of those data. So you'll see here that I have an image loaded. I'm going to actually remove that, and I'm going to go here to add data, and I have a folder here called imagery, a geodatabase, and inside of that geodatabase is a file, a raster data set called composite. This is a multi-band raster, so if I double click on this, I'll be able to see all 7 bands of this raster. So this raster has 7 bands. And if I go back up and click on that multi-band raster and hit add, it'll add all 7 of them to the map. And it gives me an image, and this is an image of the area surrounding Greencastle. And by default, it's going to assign the red band to band 1, green to band 2, blue to band 3. So red, green, and blue on the monitor are tied to band 1, band 2, and band 3 in this raster. And I can guarantee you that this is incorrect. If this is a image of Greencastle, we're seeing here fields that are showing up as blue, and that is not the true color of those fields. So if we want to change this multiband raster to what we would call a true color raster, what we would have to do is change which bands are assigned to which colors on the monitor. And it's pretty easy to do that. If I just click on this image and go to the properties in the symbology tab, I can do it right here. So you may remember that Landsat 8, and this is a Landsat 8 satellite image, Landsat 8 has band 4 corresponding to visible red, band 3 corresponding to visible green, and band 2 corresponding to visible blue. And so if I set those red, green, and blue bands in the multiband image to the red, green, and blue channels in my monitor, what I'll get is a true color image. And so here now the fields are showing up as green and brown like they're supposed to. Everything else is about the same color. And I can also play around with different ways of representing the same data. For example, if I was more interested in the infrared rather than the red, I could set band 4, the red channel on my monitor to one of these infrared bands like band 5. And if I do that, now we're seeing an infrared image of the area surrounding Greencastle. So here you're seeing the heat signature coming off of all the vegetation surrounding town. Okay, let's go back and work with a visible light image. Go back to this. And one of the things that you'll see here is that although the image is showing true color, it's kind of dark. And the reason for that is that the Landsat sensor is able to pick up a pretty wide range of brightnesses. And within that wide range of brightnesses, the Earth's surface is actually sort of dim. So this is really kind of what the Landsat sensor sees, but we can adjust the brightness and contrast of the image so that we can see things a little bit more clearly on our monitor, and I'm going to show you how to do that. The process is called stretching the image. So if I go back to the properties for this composite multiband raster, and I scroll down, there's a lot of other functions here that I can perform on that raster. Let me first show you a histogram of the data that we're looking at. There's a histogram for the red channel. So this is telling you how many pixels in the image correspond to what levels of brightness. And you can see that the red channel here is kind of dim. Most of the pixels in the image are shifted over towards the left side of this range of brightnesses, and that's one of the reasons why the image looks so dim. We can change that basically by mapping this histogram and those values on the x-axis to the brightnesses on our monitor, which we can imagine being on the y-axis. So if I do that, if I take this curve and I take just the dimmest values and map those to the dimmest values on our monitor, and then I take the brightest values, let's say these right here, and I map those to the brightest values on the monitor, what happens now is that this histogram shown in red for my monitor has changed, and I've basically taken the histogram for the raw values in the image, and I've taken that histogram and I've stretched it across the full range of brightnesses on the monitor. And if I do that for the green channel, and then I do it for the blue channel, I'll get a very different image. Much brighter, much clearer, and that procedure is called stretching the histogram for the image. And there's a lot of ways that we can stretch the histogram of an image. We don't actually have to go in and manually edit these histograms like I just did for you. What we can do instead is we can select one of the preset stretch types that's available in ArcGIS, and usually this is sufficient to enable us to see what's there. So we just applied what's called a custom stretch, basically mapping the histogram to brightnesses on the monitor in a custom way. But we can also choose one of these automated types of stretches. So if I apply standard deviations to this, a little bit washed out, not as good as my custom stretch. Histogram equalize, a little bit too bright and washed out. Minimum maximum is basically the default. You can see how dim things are if I just take the minimum values on the raster and map them to the minimum values on my monitor. Most of the values, again, are towards the minimum, so the image appears pretty dim. There are actually other types of stretches that are available to you on the ArcGIS version that you guys have access to. This is my own personal copy, and it's a little bit older, so I can't play with all of them. But I'm going to stick here with standard deviations and just work with this. So now I can zoom in and look at all of the colors in the image. And if I zoom in, let's say, to just this area right here, right there. Whoa, screwed that up, didn't I? Zoom into that area right there. Get in a little bit closer here. There we go. Okay, if I'm just looking at a small portion of an image, I can have the brightness adjust depending on where I'm looking on the image. So right now, I am taking the histogram statistics from the entire raster data set. But if I just set it to the current display extent, then it's going to stretch the histogram based on the histogram of the portion of the image that I'm looking at, rather than the entire image. So if I apply standard deviations to just this area, I should get a slightly different answer. I don't really. It is different, but it's not much different. And that is how you can play with visualizing LANDSAT imagery in ArcMap. Now in the next video, what I'm going to show you is how to take a LANDSAT image like this and classify it into a map of land use types. So I'll do that in a separate video. Thanks for watching.